So I just want to give a basic rundown of everything I've learned about x264 and encoding in the past couple of weeks. I've spent a lot of time just doing all these little tests and everything to just be to really familiarize myself with the program, and I think I've learned enough now that I can make a good tutorial about it. So I guess first here, I have a folder I set up with some batch files and x264, which is in here. I have two versions. One of them is the 10-bit version, and the other is the 8-bit version. Most videos are 8 bits. In fact, all videos up until not very long ago were 8-bit. Monitors can only display 8 bits per pixel, but there are numerous advantages to having a 10-bit video. It looks better. It's smaller, and just everything about it is pretty good. If you go to x264.nl and / this URL, which I'll put in the description, there's some PDF files that describe all the benefits. It's just a way of reducing size and increasing picture quality, basically. Now, the purpose of this tutorial is to make videos that are going to be uploaded to YouTube. So YouTube always will convert your video when you upload it. So there's no need to make your video stream compatible. You could upload it completely lossless if you had the bandwidth to do so. But obviously, if your connection isn't very good, you don't want to upload something that's going to be absolutely gigantic. So this tutorial will help make stuff that's really high quality but really small and easy to upload, and everything. I'll take care of everything, all the little technical aspects. You just have to follow along and just watch as I show what I've learned. So I'm using x264, the 10-bit version, 64-bit, just so I can use all my RAM. This site here, you can download all the stuff. I don't know if it's quite the latest version. Actually, I downloaded the latest version from the VLC website, and I had some issues with it where it was not doing stuff with logarithm properly. Anyway, so I set up a folder here with a few batch files. Also the full help here to just maybe go over some things. But for the video itself, here we have the batch file. The first thing, x264 / x264-10, that just says to go into this folder and run this program. And then threads auto, so it does an automatic amount of threads. To see how many cores your CPU has, just look here. I have 6 of these graphs here, so that's 6 cores. But this will automatically do 6, so it doesn't matter. Force CFR. This makes sure that the video is going to stay at one constant frame rate. I haven't had a problem with this before. I just learned about it. So it's just something to put in there. If you have any problems, you could remove that from the batch file. OpenGOP. This is something I read about on the x264 settings page here. Now, if we take a look, it says it increases efficiency. Some decoders don't fully support these streams, but YouTube does, so we can use it. CRF18. Now, CRF, if you look at this page here, which is linked from the x264 settings page here somewhere, it goes into depth about various methods of controlling quality and size for your video. Now, because you're going to be uploading this to YouTube, it doesn't matter if you do a variable bit rate or keep the size below a certain amount, because YouTube is always, and I mean always, in my experience, it's going to recompress it no matter what. So you want to upload it with just the highest quality possible, so all the transcoding is left up to YouTube. Now, ideally, you'd be uploading this losslessly, but obviously lossless files are going to be huge, so it's good to have something that's nearly lossless. So CRF here, 1 pass constant rate factor. It basically, you type in, or you enter in the quality. Now the highest it can go is going to be the lowest quality. So if we scroll down here, so it goes from -12 to 51. Now, I don't know why it says -12, but the default is 23. But I found that 18 can look better. But the thing is, if your video has a lot of movement, a lot of like noise and various things, you might want to set this number higher depending on the size of the file that it outputs. So you'll have to do a little bit of trial and error. But I found CRF is by far my favorite thing on this. B-frame 16, that's another thing. It slightly slows down encoding, but it just makes your video rendering higher quality, but smaller. But it just takes longer to do. Direct auto, that's another thing I found. Sub ME, it just has to do with motion estimation. You can look all these up on the wiki. The output is video.264, so it's just a raw H.264 stream. Output color space I444. Now, color space is something that really frustrated me when I was learning about this, but basically color space is just how it encodes the color versus encoding the brightness. Now, the brightness is going to be full resolution, but what YouTube and other things do for color is it usually encodes it with the 420 color space. If we look here, we can see, yes, 420. Now 420 just means that the resolution vertically is like half and horizontally it's like 1/4 for the colors. And that just means that the images could look really pixelated. Like for example here, there's a big contrast between red and blue. Now YouTube is going to convert it to 420, but if you upload it with 444, it's going to just be better, and so you'll leave all the conversions up to YouTube, which may have some sort of optimizations for that. So I just like to have everything higher quality, even if YouTube is going to just convert it anyway. So 444. Now %1, that just means if I drag the video onto here, it's just going to automatically start rendering it. And so I have these two other things here, AAC.bat, this is for encoding the audio in order to put it into a container, and wave.bat. Now this uses the program Wavy, and if I go here, Wavy, you can download it from SourceForge. I'll put all these links in the description. But Wavy just takes the audio from your AVI file, assuming that it does have actual lossless PCM audio. Now with this one in particular, I had an issue, so I can just drag this on here because it says %1, and so it outputted the WAV file here, and so it says 7 minutes 9 seconds, but I'm just going to open this in my favorite digital audio workstation, Adobe Audition 3, but I've had problems with Wavy before, in which see what we have here. After this certain amount of time, it just starts repeating the audio, and I don't know why it does that. It doesn't always do that. But assuming that you're going to be rendering this video from another program, because usually you don't just take the raw output of DxTory or something, whatever recording program you use. So the best thing to do is to make your entire video in Sony Vegas. Let's go to the default layout here. I'm just recording this whole thing in 720. I normally run my desktop at 1080, but I just want the video to be smaller and everything easier to see. So assuming I've edited this video, you would have wanted to render the video in a completely lossless format. So video for Windows and Lagarith is the best codec you can use. I just have a preset here, but we have the Lagarith lossless codec. This enable null frames. We shouldn't have this, but I'll get to that later. So you ideally would render it this way, but if the audio doesn't work with Wavy, I don't know how to pronounce it for some reason, you can just go separately and export the WAV file straight from Vegas. And so I'll do 44.1 16-bit stereo PCM. That's a good one to do. And let me just find a good place to put it. Recording x264. I set this up for the video. I'm just going to overwrite audio.wave, which Wavy outputted. So I'm going to replace it here and render. Yes. Outputting the audio is always extremely fast. I guess I can close Vegas now. Don't need that anymore. No, I'll just keep it up anyway, just in case. So now we've got the audio.wave at 72 megs, meaning it's bigger than before, obviously. So I'm just going to open it up in Adobe Audition again, just make sure it doesn't have that annoying thing at the end, the trail. I know for a fact that it will not. So it's just going to open this here, and we'll be able to determine if it's correct or not. Okay, so obviously it's fine. Our audio is the full length, and to compare it, I can go to the video here, 7 minutes, 9 seconds. Perfect. So I'm just gonna, I'm not gonna close this yet because, let's close the WAV file at least. If we see here my AAC file, it uses Nero AAC, which is a very good program for encoding audio. And you can get this on the Nero website. I'll link this in the description. It's just an extremely good audio encoder. It converts it to MP4, the MP4 audio standard, which is much better than MP3. And so if we look at the settings here, I just go Nero AAC, Win32, Nero AAC encoder. Now, if you get Nero AAC, you might have to edit the batch file differently depending on where you put it. But I just extracted it into a folder Nero AAC in the same folder as this AAC.bat. So %1, that refers to the file I drag onto it. Q1 means quality of 1, or the highest quality possible. YouTube is always going to compress it down to 192 kilobits, but it's good to not encode it at 192 kilobits in case YouTube just has some sort of optimizations it does. I don't know exactly how YouTube handles it. YouTube is basically a black box as far as I'm concerned that you can send stuff to. So I'm just going to drag the audio onto here. Now it's going to process it. Depending on the length of it, of course, it'll take a longer or shorter time, and the complexity too can really determine the size of it, because I'm not doing a constant bit rate. I'm doing a variable bit rate, so it uses the highest quality it needs to produce the best file. So I've converted it to an AAC thing. It's 8 megabytes, quite a bit of improvement compared to this, but depending on how simple or complicated the audio is, it could be bigger or smaller. So I'm just going to open this up in Adobe Audition, which I believe by default can read these, but I'm not sure. But as we can see, it's identical, same length slightly. There's like there's always going to be a slight gap at the very beginning. Now, I'm not entirely sure if my method actually produces videos. See that? It added 20 milliseconds onto the very end. So now I'm not exactly sure if my audio is going to be completely in sync. That's one thing I still never quite figured out, but I have not ever noticed any issues. 20 milliseconds also is such a small delay, you would never notice it in a video anyway. So now we've got the audio, and now the big part is the video. So I've made a video thing here, which is has a CRF of 18, which is not lossless. Lossless is supposedly 0, although this for some reason said the best quality was -12, if I remember. So I don't know what's up with that, but it's the 10-bit version of x264. So I have a video of Minecraft that's going to be really large, but I want to show another handy little trick that you can do. So I've got a recording here of a Game Boy game, so I'm just going to open it up in Virtual Dub, just to make this full screen here. So I'm just going to drag it in. Now audio, I'll just do a direct stream copy. Video, the frame rate should be 30 because the highest frame rate of YouTube is 30. So now, in order to make it look better, I'm going to resize it. And this is where the magic happens, because Virtual Dub's the only program I know that actually can use nearest neighbor to scale up video. And so the difference between nearest neighbor and one of these others like bicubic or bilinear is that nearest neighbor will preserve the sharpness of the pixels. So I'm going to set it to 1080. So now it's 1200 by 1080, perfect. And just put that fully in the view here. So as we can see, it's scaled it up perfectly. Now I'm just going to show you what it would look like if we used something like the default precise bicubic. Look at that, it's all blurry. I don't like that. I prefer the sharpness of nearest neighbor. Now, if you're upscaling, if you're upscaling normal video, you would not want to use nearest neighbor because it would look like garbage. So I got this here, video compression. Now here's the thing. With Logarithm, if you're recording, you can enable null frames, but x264, if you put a video with null frames into it, in my experience, it has produced a variable frame rate file in the output. And now you need to, if that happens, the program I use to put all the audio and video into one container before uploading to YouTube requires that you put in a time file as well if you have a variable frame rate video. Otherwise, all the null frames, all the duplicates, it'll just drop. So your video will end up being much too short. Now, you could produce a variable frame rate file, and it would actually be smaller, but annoyingly, YouTube actually screws it up, and it always gets the frames wrong. So if you have like one frame that's supposed to last for 1 second, and then the next frame is something completely different, it'll encode the next frame for 1 whole second. So it doesn't work. So enable null frames if you have that. Multi-threading, definitely. I'll suggest RGB. I guess that's good. So I'm just gonna go OK and save it as an AVI file, and just put this my recording here x264. So I'm just gonna call this GBC for Game Boy Color. And so this usually does not take long at all to render if it's a Game Boy Color thing. As you can see here, it's actually going at 150 frames a second, which is crazy. You would never have this with a more complicated video. But I just am producing this just for the simple purpose of doing a comparison. So as we see here, we got gbc.avi. It's 54 megabytes at 1080p. Now, I've encoded videos at 4K before, and it's usually not that much bigger because Game Boy Color videos especially only have a very limited color space. DOS games have only 16 colors, so that's actually significantly smaller. Now, Sony Vegas, strangely, does not actually support rendering 4K videos at in MP4s, but I don't want to deal with that at all. Sony Vegas has a lot of magic behind the scenes that I don't like. So now we've got this GBC thing here, and we've got, I can just minimize this. We've got our video thing here. Now I'm just going to copy this batch file here real quick. And I'll just rename this one to lossless. Edit that with Notepad. So I'm just going to set the CRF to 0. I remember that thing being -12, but I really don't know how this works. But I've always heard a CRF of 0 means lossless, because if we go here, lossless recording CRF 0. And I guess this thing isn't really, doesn't have the 10-bit version in mind, but we'll see. So I got lossless.bat, and I got the video here, GBC, so I'm just going to drag that right into lossless. And so it's going to start encoding it. So we can see here, CRF of 30 frames a second. It's encoding it at about 15 frames a second, meaning that this would not be suitable for real-time rendering, or at least the settings I'm using. But as we can see here, it's rendering it at about 1400 kilobits a second. It's going to be done in about 1 minute and 20 seconds or so. As we can see here, the data rate is 4,962 kilobits per second. Meaning it's going to be a significant decrease, or not significant. As we can see, it's getting a bit larger here depending on the complexity of frames. But it is going to be smaller once I do the x264. Now this video is so small, 54 megs, that you could just straight up upload this to YouTube on its own. But of course, if you want to bring it into Sony Vegas or your favorite video workstation and do all sorts of fancy effects to it, or edit your video, or whatever you want to do, you would want to put it in there and then export it again as a Logarithm file. Now the really nice thing is that if some of the frames are the same, or if all of them are the same, like if I were to start rendering this one as a Logarithm, it's already in Logarithm, and so that would actually, in this preview here, it would say re-encoding not necessary or something like that. But actually it would save you a lot of time, which is very handy. So it's good to not scale it or anything. One more thing, the reason I resized that Wario Land 2 video to 1080 is because YouTube only supports heights of 240, 360, 480, 720, 1080, and then anything after that is it'll show original as the quality in YouTube, and you can do that as well. And also the maximum frame rate, as I said, was 30. So here I've got the video.264, which is the output here. So it's a completely raw H.264 stream, 18 kilobytes. Now this is a 10-bit thing, keep in mind. So I'm going to open up MKV Merge. Now MKV Merge is a great program here. MKV Tool Nix actually is a whole suite of different things. So you can get the installer for that. But MKV Merge GUI is the one you want. So I'm going to open that up here. Now in 720, it's going to just barely fit on my screen here. There we go. So I have the video here, and I'm just going to drag it right in. So we got MPEG 4 part 10, blah, blah, blah. Don't really need to care. Language, undetermined. It doesn't matter. I could choose English, but who cares? Now, I know my video is 1280 by 720. You don't have to enter this in here, but if you want to, you could. FPS as well. It should preserve it in the 264 file, so I'm not going to worry about that. FPS, yeah, and all this other crap, it doesn't really matter too much. And so also we have the audio here, the AAC, and so I'm just going to drag that right in. This chapters thing is produced by the Nero AAC, and I really don't think it matters at all. Delay, so I could set the audio to have no delay, but I think it might already compensate for that. So I'm a bit wary about, just for purposes of this video, putting the delay in, but other people might find something different. So this is the name of the video. MKV is Matroska Video. It's the extension that this program produces. So I'm going to start muxing the file right now, which just takes both the streams and puts it into the file, which does not do any sort of re-encoding. So it's instant. See, muxing took 1 second. And so we've got video.mkv right here. It's 26 megabytes, which is a combination of the video and the audio. And so if we open up the video right now in Windows Media Player, it's just got the video completely as it should be. Everything's playing just fine. In order to actually play 10-bit videos on your computer, you'll need the LAV filters, which is at this link here, which I'll give in the description. And you'll just download this program, download the installer. It'll be set up automatically to use with Windows Media Player. Now, Windows Media Player, oddly, is the only program I found that actually displays it in the right color space. For whatever reason, VLC and all the other ones display all videos as if they have a 420 color space, which means it'll look extra pixelated, especially with like a sharp contrast between like red and blue or something. Now, you wouldn't notice it for most videos, but if you have a video with a lot of bright lights, like neon signs, like an open sign or something in front of a store, you might notice some pixelation. YouTube actually displays it okay because it smooths out the thing, but VLC does not. It displays it completely sharp, or at least in my experience. So Windows Media Player actually works best in this case, very strangely. So then, of course, you could just rename your video to whatever you want. So I'll just call it Wario Land 2 Encoding Test. And this you can upload straight to YouTube, and it'll work perfectly. And the one thing is you can't drag it on to the upload thing for some reason, whatever reason, I don't know. It doesn't let you do it. So that is a bit confusing to me. It does work with MP4s, but MKV is just, I think, going to be better for the purposes of this demonstration. So we've got this perfect video here, pretty much lossless quality as far as I know, and it's very small compared to the logarithm, and it's just amazing. If I can encoded it with a variable bitrate, say I wanted to do the highest quality possible. So if we look at the settings, if we go to YouTube's advanced, I spelled advanced wrong, whatever, advanced encoding settings, you can see it gives some things to do. your bit rate, if you have an enterprise quality connection, is 50,000 kilobits per second. If I encoded this with an average bit rate of 50,000, it would be way, way too large. So the good thing with CRF is it only uses what it needs. And for uploading, it doesn't matter. And of course, this is 27 megs at my connection speed. This would be uploaded in less than a minute. And the processing usually takes a short time, and then you'd have the video fully done. And that didn't take very long to render either. Now, of course, I had to render it in Virtual Dub, or if you're using Sony Vegas as well, you'd want to put in Virtual Dub first. But now I'm going to do the Minecraft video here. So this has got the audio in that I did. Actually, I kind of overwrote the one mistake you might have noticed that I just made actually was that I used the Minecraft video's audio in the in this file here. So of course I'm going to delete that. So I'm going to delete this as well for now. So I'm going to rename the audio here to Minecraft.wave. And so the wave program here, I should be able to drag this on and it should work fine. So we can see it did it successfully. It is 1 minute 12. I'm just going to open it up in Adobe Audition again just to make sure it didn't have that glitch. It should be fine. I outputted this from the program BizHawk, which is a great Game Boy emulator, by the way. The most accurate one in terms of video and audio. But we can see here it's fine. So now I'm going to run the AAC. Drag it on there. Look at that, much smaller. So that makes a bit more sense because I was like, why is this so large? So I'm going to drag it back in here, drag the audio back in there. I've already deleted the MKVs. I might as well just rename this right now. Start muxing. It should be just immediate. Everything went fine. Perfect. So look at that. Less than 20 megs. Perfect, perfect, perfect. Okay, now the Minecraft one. So the audio, let's just drag this into AAC.bat again. It's going to overwrite the Wario Land 2 audio, but it doesn't matter to me. As we can see here, 0 kilobytes, which means it's overwrote it. I might as well delete the Wario Land 2 audio. So it's going to just keep processing that here. Now, this Minecraft video, it's 7 minutes long, so it's probably going to take quite a bit of time to render. Usually it renders, the frame rate of the rendering depends. Now, in the full help here, you can see these presets. The profile of high 444 is allows the good color space. Now the presets here, you would never want to use something like ultra fast or super fast for rendering a video. Very slow is good. There are some things that really reduce the rendering speed. And placebo is absolutely extremely slow. You'd only want to use that if you had a beast of a computer. An Intel i7 actually has built-in x264 encoding, so that would actually increase the speed quite a bit, possibly. But you might want to leave it running overnight then, even for a very simple video. I tried to run the Minecraft video through it earlier, and it would have taken over 5 hours. Now, what this does is, what these do is it increases the video quality by whatever amount, maybe a small amount, but it does reduce the file size by some amount. Now, in combination with 10 bits and this, it might actually produce a much, much smaller video, but I doubt it would really have that big of a difference. The 10-bit is just going to save you some space and make it look better. So, and it's not much slower at all. In fact, I don't know if it is slower. I haven't actually clocked it, but placebo you don't want to do unless you really know what you're doing, because this, especially here, this is an extremely exhaustive search for motion compensation. So these settings here I just lifted from a few different sources, like tasvideos.org was one handy thing. But these settings are ones you want to keep, and of course lossless we have to with a CRF of 0. The Minecraft one, if it's lossless, it's going to be huge. So I'm just going to drag the thing right into video.bat, and it's going to index the file, which does whatever it does. I'm not exactly sure. I don't know if you can output this index beforehand. There's an index that you can put into MKV merge, but because it only takes like a second anyway, unless the video is going to be absolutely gigantic, in which case it might take a whole 10 seconds. It doesn't matter. So I'm just going to let this file index here. And as we can see here, it's on the command line, it's fine. The input file is minecraft.avi because I did the %1 here, which just is whatever you send into the batch file. So it's just going to finish indexing, doing its thing here. Now you'll see it's already created video.264, overwriting the other one with no actual warning. So just keep that in mind in case you want to do stuff. Okay. We can see here 1280 by 720, 30 FPS CFR. It's converting from RGB to YUV 444. That's good, that's fine. And here we go. Frame rate of about 5 FPS, but that is going to increase. Another thing is that, of course, I'm recording at the same time, recording from Fraps, so it might actually end up being being faster if I turn off Fraps. And I'll want to do that anyway because this file is going to take quite a long time. Even if it won't take 20 minutes, it might still take 10, and I don't have enough to talk about for 10 minutes. So I don't know if I really even need to show the output video necessarily. It's going to look almost lossless, but you might as well trust me in the fact that I already did a video. This one, I might as well just let this go as I'm editing this video, and then I'll just record the results. Whatever, you'll see what happens. We'll see. Alright, the video has been fully encoded, so now I'm going to take a look and see what it looks like. So, 292 megs, that's kind of large. If I had done a higher CRF, it would have been a bit smaller. Probably would have looked just fine anyway. With my upload speed, actually here's a good way to calculate it. So I know my upload speed is 5.25 megabits per second, so 5.25. Now if we divide that by 8, that's 0.65625 megabytes per second. So that's 292 megabytes, and so we want to know how long it's going to take to upload, so here's what we do. So it's going to take about 445 seconds, or divide that by 60, 7.41 minutes, well, minus 7 times 60, so 7 minutes, 25 seconds. At the very least, it'll take just a little bit longer than the entire length of this video to upload. So that's pretty good. But I could have done better. I could have done different settings. There's no need to, but let's just put in MKV merge and see what it looks like here. Audio. This is the right audio this time. Okay. Everything should be good. Don't need to change anything here. And I'll do Minecraft encoding test. See, it takes a little bit longer to index because the video is longer or bigger. 7 seconds. Pretty good. Minecraft encoding test. So 301 megs. So actually, of course, it'll take a bit longer than my previous estimate because clearly the audio adds a little bit onto the size. And here we go, playing at full speed. I have the sound muted on the video anyway, but the sound is perfectly in sync. I'm listening to it right now. Yeah, the audio is great. Video seems totally fine all the way through, even parts with like a lot of darkness, which normally encoders struggle with. It looks fine on my computer. Obviously, once this is uploaded to YouTube, it could look worse because unless you're uploading videos in 1080p, there's actually the quality is probably going to be significantly worse. Also, don't ever dig straight down in Minecraft. This is dumb. Anyway, so to sum things up, x264 is a great little tool for rendering or for encoding your videos after you've rendered them. And it's not a one-size-fits-all program, and all the settings I provided might not work for every single video, such as the CRF, so you'll want to go into the batch file and change that. Remember, the higher the CRF, the lower the quality. The default's 23. So for this video, I could have probably turned it up a bit more, and therefore the size would have been smaller, and I'm sure that the whole video would have looked fine. It looked barely any different on YouTube. But just keep in mind, you want the highest quality stuff before uploading. And lastly, there are frame server plugins for Sony Vegas that let you encode to x264 directly, but it loses a lot of stuff like the video's actual size, the frame rate, and everything. And it's like this big chain of different applications. I looked into it. Like supposedly there's simpler ways to do it, but from what I saw, it was pretty complicated. But this here, what I've done, what I've shown, is what I found works the best for me, and this makes a very acceptable workflow. So in the video, I'm not going to obviously provide the applications, but I will provide the batch files. The applications are all free, available to download, of course, except Sony Vegas. Virtual Dub also is a good one to get. I'll just put a link to that in the description. But of course, once you're done here, it might be good to have a batch file that automatically does all this, and I have done that before, but you'll always want to just take a look at it anyway. So I'm just going to clean up here. So we got this I don't need, this I don't need, this I don't need anymore, this, and just remember to clear everything out once you're done, because otherwise the folder can get pretty large, and you might be able to output it to other folders too, like that you could make an output folder. It's up to you. With batch files, you can do a lot. I've only briefly touched upon all the possibilities with this method. So if you have any questions, just leave them in comments or private message me. Do whatever. I'll do my best to help you out. But thanks for watching. Bye.